We are ready to go, so take it away.
Am I sharing? Um,
Yes, you're sharing your slides. We see them.
okay. Do you want me to share our have our camera on?
We can't enable our webcam.
Oh, so we don't have to share our camera. Well, hello everyone. Um, Welcome to our presentation. We are so glad here today to have the opportunity to present our research project on using AI tools to generate descriptions and subjects for the video of silent films. Our presentation will showcase where we are on this project and what we find out, also the next step of this project. My name is Mingyan Li. I'm the metadata librarian of University of Illinois, Chicago Library. And there are all the presenters here, including Eric Cho, who is an independent researcher, and he is former digital scholarship manager of Hong Kong Baptist University. And also my colleagues from University of Illinois, Chicago, Kvita Mando, who is the head of resource and acquisition management, and Ian Collins, who is a digital services librarian from the University of Illinois, Chicago. Our presentation today will start with some background information of our project. So, Ian, please take it away.
Well, I'll note that, one of the motivations for this project is that there's always a backlog and there's always more coming. So that's one motivation for us taking a look at this. So could you hit the next slide? Oh, I think we missed one. I'll just actually just say a quick background about the actual collection of the videos. So okay, so
Here
we
it
have
is.
so the bigger it's a bigger collection. It's a bigger AV collection that has sound. It also has images and things like that. But we also have 786 silent videos in this collection. They're color, they're black and white, made by different creators, different filmmakers. They are H.264 codec and MP4s in this case of the project. So like we have master versions, but these are the derivative files. The videos range from 40 seconds to 30 minutes. And we ended up using around 26 to, I think we ended up starting to add more lately. So we might be near 39, but we started out with like a quick 26. But a lot of the work has been done on the collection, for the past couple of years. Like this is such a big undertaking that it's taken us a while to get a lot of the things up and out. And because that work has taken years, we can at least compare with what the AI prompts are giving us. So like I said, there's always a backlog. There's always stuff coming, so we're trying to take that on. So I will pass it to Eric to talk about some of the prompt, large language models, and things like that.
All right, thanks, Ian. So since large language models like ChatGPT started to gain traction about 2 years ago, one frequent use case is actually chatting with your document. I'm not sure if you use it before, but that actually means that you can upload a textual document like a PDF or Word file into the LLM and ask it to summarize it or query specific questions whose answer lies in that document text. Now, late last year in 2023, Gemini, an LLM released by Google, took a step further and allow users to input non-textual data, such as videos, so that people can now chat with your video. So basically, ask and extract information from the visual contents of the video from the LLM. So this kind of LLM is actually called a multimodal LLM. So for this current experiment that we're conducting, we wanted to test out Gemini's ability to quickly generate summaries of videos. We will also be exploring the generation of metadata for the video contents for cataloging purposes. So next slide, please. Now I'm going to go over some specific details on how we operated Gemini. So like any other LLMs, they rely on us to the user to chat with them through prompts. So a well-crafted prompt can actually do a lot in terms of information retrieval from a given piece of content, whether it's text or video. So this is what our prompt looks like. So notice that we have structured the prompt in a very specific way, and there are two parts to it. So the instruction, which is boxed in red on the top, and an example of input-output pairs shown inside the green box below it. So which actually the example is what we want Gemini to use as a reference, so it can output exactly what we desire. So in this case, we wanted to output into the output into JSON format so that we can easily ingest the result using Python script into an Excel file later on. Now, in the instruction, going back to the instruction, you can see that we're trying to be as specific as possible about what we want it to do. For instance, we asked it to figure out the number of narrative scenes and assign timestamps to them. So we also wanted to extract any text or writing shown in the videos, such that those on the billboards, signs, posters, or even those clapperboards that appears in numerous instances of the video. So next slide, please. So to test out the prompt, we use the Google Vertex AI platform on Google Cloud Service. It's sort of like a chat interface, but with a bit more setting to play around with. So on the right-hand side, you can see that we can select different Gemini models to use. So we are now using Gemini 1.5 Pro at the moment. We also set the temperature setting to 0. So temperature setting basically tells the LLM how creative we want the output to be. So if we want the LLM to write a creative story for us, then we'll set the temperature to high. But if we want, in this case, do some precise information retrieval work, it's best that we set it to 0. So on the left-hand side, we would input the prompt in the white space above, okay, as well as attaching the video that we want Gemini to analyze. And then when we press play or the run button, the output of the LLM, namely the transcript and all the information we have asked it to extract, including the timestamp, would appear in the JSON format in the response area. So next slide, please. So we use the Vertex AI interface to simply test out our prompt and see whether it gives us the desired output. So after we're happy with the prompt we've crafted, then we'll need a way to apply and query the LLM repetitively over many, many videos in the repository. And we do that using Python scripts to call the Gemini API repetitively. Now, in the interest of time, I'm not going to go over the code, but I've recently conducted another experiment in using Python to read a series of book records and generate Library of Congress subject headings for them. So you can see that actually the code can be found in the link on the slide shown here. It works actually quite similarly, except that it's analyzing textual content. So I suggest if you're interested, you can go check it out. And also in case if you're interested on the topic of using ChatGPT to generate LSESH headings, you can also check out an article I've written, and the link is also shown in the slide. So now I'm going to pass the time to Mingyan to continue talking about the testing procedure itself. Thanks.
Thanks, Eric. With the prompt Eric just showed earlier, we have started to test the AI-generated metadata for total 39 silent videos. To better evaluate and compare the results, we decided to test both with or without raw metadata. The raw metadata here we refer to is actually created by our colleagues from our digital services and programs. To summarize those silent videos, they actually need to watch the films over and over again, which was a quite time-consuming task. In the first round of the testing, we didn't include the raw metadata. And the raw metadata will be included in the second round. The result will be coming soon. So far, we finished the first round of the testing and got the result. After finishing the 2 rounds of testing, the 2 sets of test results will be analyzed and compared. This will be very helpful for us to decide the further workflow and the best timing for human intervention in order to improve the effectiveness and efficiency of the workflow. As for now, we can see that the test result from first round of testing This column is a description created by AI, and this column is original description created by our colleagues, which is not included in this testing. As we can see here, the Google Gemini has been caught some very good informations. Even for some of this, they identify it's a city of Chicago, which is very encouraging. And some of the things are identified. However, we also notice it actually lacks an accurate summary of the video content, which is very important to help the users to catch right away what the video is about. So this is how the description looks like. And this slide shows how the AI generated the captions. We use the 3 records as our samples. It's the same 3 records from the previous slides. These 3 records all consist of many clips, which are the repetitive filming of the same movie scenes. The wording on the clapperboard was recorded as caption. So one of the records actually has up to 27 of them. So it took a lot of time for our cataloger to input those data. In this case, we can see AI actually did a very pretty good job catching all these words and record them. The only difference between the AI generated one and the cataloger created one are marked in red. As you can see, it's pretty accurate. So that is a brief review of the testing result. And now Kavita is going to talk about our future testing.
I know we are running short on time, so I'll make this really quick. As you all see, this is a work in progress. We have just finished our first round of testing. We are going into the second phase of testing, and that's when we intend to submit our raw metadata. Generate descriptions, captions, take a look at them, and then also use ChatGPT to generate subjects. We also would like to survey the collection because it's huge. It takes really long time for all of us to go through. So I think what's there in the collection. Are there any duplicates? That's another consideration that we have, because we do think that there might be some duplicates. So we are trying to figure out the process and the workflow to make sure that we can really and easily identify duplicates, which would really save our time. And again, with all these projects, these are all experiments. So we also want to see what would be the best time for us to do intervention. And that, though these are some of the considerations and these are, some of the future testing plans we have. With this, I want to pass it on to Ian, who would just, who has a concluding slide and, who would go more into the details of doing the evaluation and, the plans that we have for future evaluations.
Yeah, so 4 very quick bullets. We're going to evaluate evolving terms of service. Google changes their rules and ideas all the time. The ethics, obviously ethics with AI, where it fits in our workflow, things like that. How we're going to maintain the script, and also checking in more with our archives colleagues. So getting more of their input. So thanks, everybody. Send us questions if you have any, and we appreciate it.